Yes. So, yes, madam, we may start. Hello and very good evening to everyone. Our today's and final speaker of this online mode of the FDP is Dr. Sipana Shah, ma'am. A very warm welcome to you, ma'am, for joining us in this FDP. I'm going to introduce about our resource person. Dr. Sipana Shah is currently serving as an associate professor in the Department of Computer Science and Engineering, IIT Patna, India. She has authored or co-authored more than 300 papers. Her current research interests include machine learning, deep learning, bioinformatics, natural language processing, multi-objective optimization, and biomedical information extraction. Her H index is 33, and the total citation count of her paper is 6,368, according to Google Scholar. She is also a senior member of IEEE. She is the recipient of the Google India Women in Engineering Award for the NASA Young Scientist Platinum Jubilee Award 2016, Bird Award 2016, IEI Young Engineers Award 2016, ACRB Women in Excellence Award 2018, ACRB Early Career Research Award 2018, Humboldt Research Fellowship, Indo-US Fellowship for Women in STEM, Women Overseas Fellowship Program 2018, CNRS Fellowship. She is currently also serving as the associate editor of IEEE ASIM transaction on computational biology and bioinformatics, IEEE transaction on computational social systems, ASIM transaction on Asian and low resource language information processing, expert system with application, PLOS1 machine learning with application. She is in the editorial board of IEEE Internet Computing. This is one of the top magazines in the area of internet technology. IC 2019 impact factor is 4.231, 2-year impact factor 5.277, H index 103. Engineering application of artificial intelligence, Elsewhere journal. Her name is included in the list of top 2% scientists of their main subfield discipline, artificial intelligence and image processing. Across those that have published at least 5 papers, a survey conducted by Stanford University. So thank you, madam. So over to you, madam. You may start, ma'am.
Yeah, thank you very much, Dr. Dilip, for inviting me in this workshop. And yes, so today I will talk about AI/ML applications in digital health. So in IIT Patna, we have a team, we have a group basically who are working on AI/ML techniques and their applications in natural language processing and bioinformatics. So I will discuss about some recent applications of AI/ML techniques for solving some problems related to digital health. And then if time permits, I have asked my student also to join. So we will also give you some demo, like whatever approaches I will be discussing. I will ask, so my PhD student, Mr. Abhishek Tiwari is also here. So he is a student, he is basically supported by Prime Minister Research Fellowship. So this is a very prestigious fellowship, and very few students used to get this fellowship awarded. So he is one of them, and he will also try to show you some demo of this whatever I will be discussing. First, I will discuss about the theory part, and then, if time permits, we will also show you some demo. So yes, so this is my web page. So all the publications related to this particular topic are listed in my web page. So you please visit my web page to get more information about the works that we are doing. You can get the publication list from there. And also you can write to me. My email addresses are sripona@iitp.ac.in or sripona.shaha@gmail.com. So you can also write to me, and I am extremely sorry, actually. I am little bit suffering from cough and cold, so maybe my voice will be little low, but I will try to speak as much as possible. So this is the today's topic. So I will discuss about the development of basically development of some virtual doctor. So like, suppose you are going visiting a hospital. So in a big hospital, there are many departments, and there used to be a receptionist, and in the to the receptionist you need to mention about your problems. So there is a self report card. So the self report card, you have to mention the symptoms that you are suffering from, and then based on the symptoms, the receptionist sorry, the receptionist used to guide you to a particular department. And then in the department there are some senior doctors and some junior doctors. So these junior doctors are mostly responsible for symptom investigation, and there is a senior doctor. So after doing the symptom investigation, the report is given to the senior doctor, and the senior doctor basically does the disease prediction and also prescribes some medicines. So there, how can we replace the junior doctor by a conversational agent? Like, you all know about the conversational agent like Alexa, Siri. These are the examples of the conversational agents, and we are regularly in our day-to-day life, we are using Alexa and Siri for solving various tasks. So can we also develop some virtual doctor? So this virtual doctor will try to replace the junior doctors. So that is the first work. And the second is basically the development of some motivational chatbot. So we are also working on, can we develop a virtual counselor? So suppose somebody is suffering from depression or some mental disorders, we need to have a counselor, and the number of counselors or number of psychiatrists in India is very limited. So in that case, can we somehow, develop a conversation agent like Alexa or Siri, which can try to do some virtual counseling? So this chatbot will be the first point of contact who is suffering from some mental disorder, and then depending on the mental disorder type, the bot will try to try to generate some motivational utterances to motivate the user. So, and then we have also worked on developments of some AI-based tools and techniques for cancer prognosis. So, for the cancer patients, if we have information of multiple modalities, like suppose we have the genetic information, we have some clinical information, we have some images of the cancer tumor, considering all the information, can we predict whether the patient is going to survive for more than 5 years or less than 5 years? So we can put a threshold, and then we can try to estimate the lifetime of particular cancer patient based on the current situation. So we can have some genetic history, what is the family history of the patient, what is the clinical information of the patient, what is the some features from the images. So basically we are working on the breast cancer. So we are working with these different modalities, we are extracting features from different modalities, and then we are deciding whether the patient will survive for more than 5 years or less than 5 years. And then we are also working on developing some AI based tools and techniques for COVID detection. So, given a chest x ray, can we automatically say, like by the help of AI based image processing tools, can we say whether the patient is suffering from normal pneumonia, or it is a COVID 19, or maybe it's simply flu? So basically, these are the different tasks that we are doing in our lab, and yeah, so I would like to discuss them one by one. So artificial intelligence, if you see, artificial intelligence means that we want to infer some intelligence inside a machine artificially. We want to make a machine intelligent enough, and the machine, basically the idea is that we have some human intelligence, which is a natural intelligence. Can we artificially make the machine intelligent enough so that it can help us in solving some particular task? So there are many tedious tasks, or there are some, automated tasks. So can those be solved by the AI based techniques? So artificial intelligence is a popular branch of computer science that concerns with building intelligent smart machines capable of performing intelligent tasks. And there are various approaches for making a machine intelligent, and one such approach is called the machine learning. So how to make a machine intelligent enough? So basically with the help of the data, so data is basically the oil. And with the help of the enough data, we can build some models, and then we can make the machine intelligent enough. And also deep learning is another subset of machine learning. So here we are working with the deep neural network having multiple layers. So with rapid advancements in deep learning and machine learning, the tech industry is transforming radically. So AI has huge applications in all the spheres of life. So you can take any particular sector and you can see the applications of AI there. It could be healthcare. So today I will discuss about the healthcare related applications. But you can also consider the theme of this particular workshop is agriculture. So for predicting the weather, or whether which kind of crops should be basically developed in a particular area. So all those the decisions can be taken by the AI based system. So real time operations management. Then in customer services, mostly we are replacing the receptionist by the conversational agents. Then risk management and analytics. So we can easily discuss in the banking sector, AI-based tools and techniques are heavily used. So we can decide whether the person will be given some loan or not. So by the use of the AI or ML-based techniques, customer insight, pricing, and in order to decide whether the what will be the price of a particular house. Suppose you want to sell a particular house, so you know the location of the house, you know the age of the house, you know the number of bedrooms in the house, so you can easily estimate the price of the house. So then research and development, knowledge creation, in fraud detection, whether a particular transaction will be fraud or it will be legitimate. So that can be easily decided by the AI based techniques. So we can easily find out the patterns. So suppose the user is using a credit card, and mostly he or she is making transactions of less than 10,000, and that too in the daytime. So now if there is a transaction in the night and that is also amounting more than 10,000, then we can assume that maybe most probably this will be a kind of fraud transaction. So fraud detection is also a very important task of machine learning. So supply chain, customer experience, so everywhere. It could be predictive analytics, it could be real-time operation management, customer services. So you can take any particular sector and you will see a application of AI there. So basically, now let me discuss about the virtual assistants or the chatbot. So chatbot, that chatbot is nowadays very popular in our day-to-day life, because Alexa and Siri we are regularly using. In our home, we are using Alexa. We are asking Alexa to about the weather report, or we are asking Alexa to play a song. Or there are some sophisticated conversational agents as well, which can help us in booking a restaurant or booking a flight ticket. So basically, we investigation of role of human-inspired learning in developing intelligent virtual assistants. So we can have different types of virtual assistants. So basically, we have some virtual counselor. We can have some diagnosis agent. We have some customer service agent. We have some sales agent. We have some e-commerce agent. So like virtual counselor, I will discuss today that how can we develop some chatbot for the motivational purpose. Personal assistants are basically mostly Alexa and Siri, which are used to solve some particular problem of ours. Then I will also talk about the diagnosis agent. How can we develop a virtual doctor? So then maybe a virtual assistant or a conversational agent can also help you in selling a particular product. So basically, it is a very intelligent chatbot which will try to understand the user specification first, and then it will search in the database. So if the item is not available, then the agent will try to pursue the user to buy some alternative product. And once the item got fixed, the agent will basically negotiate the price. So persuasion, negotiation, these are some human qualities. So we can also infer those in a chatbot. So people are working on developing some sales agent with all these attributes, persuasion and the negotiation. So basically, mostly all this virtual agent development is kind of a human inspired learning. How you used to learn a particular problem. So that kind of intelligence we need to infer into a chatbot. And obviously it is not possible without the data. So suppose if you want to develop a sales agent, we need to curate those kind of data, where the patient where the customer will ask about some product, then the bot will ask about the specifications of the product, then there will be database search. If the database, if the product is available, then there will be a negotiation on the price. Otherwise, if the product is not available, then there will be persuasion on some alternative product. And this persuasion will also be based on, different characteristics of the person. So if we know that person is very emotional, then the persuasion will be based on emotional appeal. If we know the person will be logical, then the persuasion will be based on some logical appeal. So depending on the personality of the customer, there will be different types of persuasion strategies. And once the item got fixed, now the agent will try to negotiate on the price. So all this human intelligence we have to infer, we have to somehow, we have to inculcate inside a conversational agent with the help of data. So that data, with the help of data only, we can inculcate this kind of intelligence. So yeah, so basically, that this is the overall diagram of a conversational agent. So conversational agent is having mostly three components: natural language understanding, dialogue manager, and the natural language generator. So the natural language understanding aims to understand the communicative intention of the user, what the user is trying to say. Suppose user is saying something, so first, before answering the user, the conversational agent has to understand the communicative intention of the user. So what is the type of the utterance? Whether the user is asking a question, or user is only delivering a statement, or there is only a greeting. So the type of the question we need to understand. And then there is a spoken language understanding module, which will try to identify the intent of the utterance, and also will try to extract the slots from the utterance. So basically, that intent means, suppose the user wants to book a flight ticket, or the user wants to, book a restaurant. So these are the possible intents. Or user is only interested in knowing the price of a particular price ticket. So these are the possible intents. And the slots are the important information which can be extracted from the user's utterance. So given all these, we will generate the state, and this state is basically consisting of the dialogue act, which is a type of the utterance, then the intents and the slots. So given the state space, the state is given to a dialogue policy. So dialogue policy is a kind of a, kind of a reinforcement learning based agent. It will map the state into action. So given the current state, it will map to a particular action, and then the action will be translated into a system response by the natural language generation module. So dialogue policy is a reinforcement learning based agent, and natural language generation will basically generate the system responses, and these responses will be finally translated into speech signal by a text to speech module. So this is the overall diagram of a end-to-end dialogue system. So we have mostly three components: natural language understanding, and then dialogue policy, and the third is the natural language generation. So as this is a online system, so if there will be any problem with the internet connection, please let me know, because you know that in the online, as I am not able to see you. So yeah, so if there will be any issue, so Abhishek, I am fully audible, no?
Yes, ma'am, you are completely audible.
Yeah. Yes, so now let me discuss about one by one that I told you that first of all, we'll discuss about some virtual doctors, and then we will discuss about some motivational chatbots, and then we will also discuss about some cancer prognosis systems, and finally some COVID prediction systems. So let me start with the concept of virtual doctor. So you know that why we need to have a virtual doctor. So, disease diagnosis is a very important task, and because nowadays, because of the COVID and 19, as we're working from home, and sometimes there is a quarantine issues, we sometimes do the e telemedicine. So we used to consult the doctors over phone, and also sometimes we used to search in the internet regarding our symptoms, and we used to get information from the internet, the diseases that we are suffering from, and the possible solutions for the same. So and also the world falls short of 7.2 million medical workers. So by 2030 it will be 30 millions. Most of the countries across the globe have only 0.01% to 0.1% doctors. So if you see the ratio of the doctors and the patients, it's very alarming. So there are very few doctors for the developing countries. Like if you see India, developing country like India, the number of doctors is very limited compared to our population size. So a survey, who has conducted a survey, and which has shown that 35% US adults had utilized self-diagnosing tools before consulting with the doctors. So thus, efficient time utilization of doctors and early diagnosis are two key motivations for disease diagnosis assistant. So this is our idea, that we would like to develop a virtual assistant or the conversational agent, which will act as a virtual doctor, which will do some symptom investigation. So our motto is not to replace the senior doctors. We really would like to reduce the burden of the doctor. The symptom investigation will be done by a conversational agent, and then finally it will generate a report. It will also predict some possible disease based on the symptom investigation, and this report will be given to the senior doctor. Senior doctor will further verify the disease, and he or she will prescribe the medicine. So basically, this is the overall flow of our approach. So initially, when the patient visits a hospital, patient will submit the self-report. So from the self-report, the department will be decided, because a particular hospital is having many departments like cardiology, skin, eye. There are many departments inside a particular hospital, and then each the hospital is having some junior doctors and a senior doctor, and this junior doctor will basically perform some symptom investigation. It will ask some additional symptoms. So basically, when we used to visit a doctor based on the self report, doctor first assumes some disease, and then doctor used to investigate some more additional symptoms, just to confirm the particular disease. So basically this is a like a opposite direction. So basically based on the self report, doctors used to assume some disease, and further symptom investigations are done to confirm the particular disease. Similar way will be carried out by our virtual doctor also, and it will do some symptom investigation. And there is another advantage, like sometimes maybe the symptom names are not known by the patients, because there are mostly rural, there are many people who are coming from the rural areas, so they may not be aware of the appropriate symptom name, like mouth ulcer. So maybe many people may not be aware of this particular symptom name. So the patients can also show some symptoms using the images of the signs. Like some symptoms can have signs also, like skin rash or the mouth ulcer can have their corresponding signs. So basically, our model is also capable of extracting the symptom information from the available signs. So that way, it is. Yes. Any question?
No, ma'am. I thought your slide is not moving. Maybe you're talking
Oh
about the
no,
same slide.
no.
It's the title is automatic disease
Yeah,
diagnosis.
yeah, yes, yes. Yeah, I'm here only. So
Okay, okay.
basically, that is the yeah. So basically, we are working in the multimodal space. So where the patient can either mention about some symptoms either through images or through text. So this is the motivation of developing the virtual doctor. Like you can see, it will work like this bot. The responses of the bot will be automatically generated. Suppose the patient is saying, "Hi, I have been suffering from fever for a few days. Also, something happened in my mouth. Please see this." So you know that here fever is a kind of a symptom, and also it is showing some image. From the image, you have to understand that this is the image of a mouth ulcer. So fever will be automatically identified as a symptom, and also from the image we will extract the information of mouth ulcer. Now the bot is asking question, did you recently vomit? So you can see this green are the responses of the bot, and the red or this pink colors are basically from the customer, from the patient. So basically, yes, I vomited recently. So basically, vomiting is a symptom now. Now again, the virtual doctor is asking, do you have eye pain? Yes, I am feeling so. So eye pain is now a symptom. Have you observed any skin rash in your body? So again, the patient is not mentioning in text. Patient is showing some image, and from the image you have to identify that this is an example of a skin rash. Finally, this report will be generated. The patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, skin rash. The most likely disease is erythema multiforme. The images are shown below. So it will generate this kind of report, and also it will based on the symptoms investigated. There is a disease prediction module. So it is a classification module. So it's a hierarchical classification. So this disease prediction module will first try to identify the department name, and then for each department there are some diseases. So next it will try to identify the disease name. So and also it will add the images. So this report will be given to the basically the senior doctor, and now the senior doctor will investigate the report, and it will also confirm the disease, and then it will accordingly suggest some meditation. So this is the overall architecture, that overall goal of our virtual doctor. And there are several research problems associated with this particular objective. So while we are developing the virtual doctor, there are several research problems. One is the knowledge infused context driven disease diagnosis. Like that we should have a external knowledge base, because doctors are very much knowledge, yes, and doctors have a kind of a knowledge that yes, these symptoms are related to a particular disease. So somehow when we are making a automated system, we have to somehow input those kind of knowledge base also. So there is a knowledge base, and that should be a part of the virtual doctor. So before generating any response or before any symptom investigation, the virtual doctor has to consult the knowledge base, and then accordingly the symptoms will be extracted from the knowledge base, and accordingly questions will be asked. And also context plays a very important role. Like basically the symptoms which are already present, those can help in further symptom investigation. So each, some symptoms are very common across many diseases. So that's why sometimes, the sequence of symptoms which are investigated also is also very important. And then symptoms are known by their companies. As I mentioned that there are some common symptoms for many diseases, but the sequence of symptoms is also very much important. The sequence by which symptom investigation is done is very much important. Then third is the multimodal automatic disease diagnosis. Here, the patient can also show some symptoms through the images. So patient can show some images, and then from the images, we can extract the symptom information. And then fourth is learning from failures. Diagnosis assistant that also learns from unsuccessful diagnosis. So basically, that so doctors used to learn from failures. So if there are fail cases, doctors used to learn from the failures. So similarly, can our virtual assistant also learn from the failures? So these are some works that we are doing with the now basically Abhishek is doing leading this work, and the first work is accepted in a category A conference. Second one is also accepted in BNC Bioinformatics. Third is also I got accepted in a conference. Fourth is also it is also accepted in EI, activity transactions on EI. So now let me discuss about the first work, a knowledge-infused context-driven dialogue agent for disease diagnosis using hierarchical reinforcement learning. So diagnosis process, so basically here, if you have n number of symptoms and d number of diseases, so total search space would be to the power n minus 1 to d. So many, it's a large search space, and so many possibilities are there. So, to reduce the number of possibilities, we need to consult some, external knowledge base. So there is a knowledge base, and then which is a kind of a knowledge graph, which can be consulted to understand which symptoms are associated with a particular disease. And also in real life, doctors usually do not go from the informed symptoms to the disease. Rather, based on the self-report, they assume some disease, and then they did some simple investigation to confirm the particular disease. So they hypothesize a set of candidate diseases depending on informed symptoms, current context, and first inspect symptoms of candidate diseases. So our contributions are a novel, knowledge-infused, context-driven, task-oriented virtual agent is developed for automatic disease diagnosis using hierarchical reinforcement learning. And our proposed, we have to also developed a disease classifier. So this disease classifier is also hierarchical. It first determines the department name, and then for each department there is a set of diseases. So in the second stage, it determines the department disease name. And a huge improvement over current state-of-the-art model. So there are some current state-of-the-art model, but we are able to improve the results by 7%. So this is the overall diagram. So this master is the receptionist. So the master first, the patient has to report to the master or the receptionist. Then based on the self-report, the receptionist has to refer to a particular. These workers are for various departments. So basically, the based on the self-report, the receptionist will send the patient to a particular worker or a particular department. And now there is this hierarchical disease classifier which is predicting some disease, and then it is predicting some possible diseases. And the pathogen is our external knowledge base. So we are extracting the possible symptoms from the pathogen, and then if that particular symptom is also asked by the virtual agent, then the virtual agent will be given some reward. Otherwise, there will be a penalty. And then you can see that there is a state tracker, and there is a user simulator. So this user simulator is generating some responses, and this internal critic, learner critic, and the worker confidence critic are some reward functions. So these are generating some reward or the penalty. Because it is a reinforcement learning based agent, we do not have any sufficient training data. That's why we are working in a reinforcement learning based scenario. So here, whether the virtual agent is doing right or wrong, so that is decided by the reward or the penalty. If the virtual agent is doing right, then there will be more reward, and if it is doing wrong, then there will be penalty. So basically, that way, basically, we are developing this model. And this is our proposal. This is the basically the background of the virtual doctor. So this whole architecture is developed by us, and then we have applied this architecture on some data sets. So there are 4 data sets are already available: RD1, RDDX. These are some Chinese conversational data sets. So these data sets have this kind of conversations that patient is asking about some patient is some there is a doctor who is asking some symptom investigations, and the patient is answering. So these kind of conversations are there in these 4 data sets. So 2 datasets are in Chinese, and like in RD, the number of users are 710. In DX, number of users are 527. And RD and the DX are very small datasets because number of diseases are also limited, 4 and 5. And number of symptoms are also limited, 67 and 47. But if you see the SD synthetic dataset, which is in English, there are 30,000 users and 90 diseases, and there are 266 symptoms. And all these diseases like dengue, fever, diabetic, all these are basically part of this particular data set. And there are symptoms like sore throat, fever, ankle pain, shoulder cramps, etc. And this MDD data set is also in English. There are 1912 number of users. There are 12 diseases and 118 number of symptoms. And you can see these are the different esophagitis, enteritis, asthma. These are the part of the diseases, and the symptoms are the dizziness, chest tightness, burning sensation behind the breastbone. So these are the possible symptoms. So these are the references of these data sets. So we have worked with the English dataset only because we do not understand the Chinese. So we worked on the English dataset, and these are the results. So basically, as this is the reinforcement learning based agent, so we have to plot the learning curves, whether the reward function is keep on increasing or not. If the reward will be keep on increasing, that means the system is learning something. So basically, these are the curves. So you can see there are different versions of the proposed approach, and we have shown the learning curves over the different success rate over different epochs, and the success rate is keep on increasing, and finally there is a saturation. So this results in also dialogue length. So dialogue length indicates in how many utterances the agent is able to capable of identifying the disease. So the dialogue length should be minimal. So we want the minimum number of utterances and by which the agent should be capable of identifying the disease. So so basically we are comparing in terms of 5 metrics. Success rate means in how many cases there is a success. The agent is capable of capable of doing the correct symptom investigation and also predicting the disease correctly. Dialogue length, basically our aim is to that with minimum number of symptom investigations, the agent should be capable of identifying the disease. AMR is the basically the average matching rate, which is the n by n. So you can see n is the number of extracted symptoms with ES information. Capital N is the total number of taken turns. Human satisfaction will be high. So basically, and then SIR is the symptom investigation rate, which is n by NL. N is the number of expected symptoms with ES information, and the IL is the length of implicit symptom set of patients. So basically, if the AMR is high and the SIR is high, that means the most of the symptoms, user is saying yes. So user will be more satisfied that the agent is asking about the correct symptom information. And the disease classifier accuracy is also one important factor. So you can see that we have compared with the many existing techniques, and we are getting around 59% disease classification accuracy. And for the MD dataset, we are getting around 77.85% disease classification accuracy. So this is the one example you can see, like this is one example, one case study that we can see. Do you have any sharp abdominal pain? Hi, I have vaginal bleeding after menopause. I am also feeling anxiety and nervousness. Can you please tell what could be the disease? Okay, do you have sharp abdominal pain? No, I am not feeling abdominal pain. Do you suffer from painful menstruation? No, I do not feel painful menstruation. Have you encountered unpredictable menstruation? Yes, I have unpredictable menstruation. Are you feeling involuntary urination? No, I have not encountered such problem. Have you seen spas in sputum? No, I have not seen spas in sputum. Have you felt hot flashes? No, I have not felt so. So, do you had long menstrual period? No, I had not encountered long menstrual period. Okay, do you have pelvic pain? Yes, I have pelvic pain. Okay, you may have a domerial cancer as per the symptoms. So see, this way it is basically predicting the disease. So you can see like how the different agents are performing. So when we are comparing with the other agents, their behaviors, what kind of responses are generated by them, that is also illustrated here. It's a kind of a case study. So now, next, what we have done is that we have worked on the multimodal space. So multimodal means that sometimes user is not aware of some symptom information. So user is not aware of some symptom name. Rather, user can show some images to refer to some symptoms. Now, our model should have an image identification module. So this image identification module should be capable of extracting the symptom information from the images. So in real world, when we consult with doctors, we often report and describe our difficulties or symptoms with visual aids. In fact, many people are unacquainted with several symptoms like mouth ulcer or the skin rash. They do not, in general, they can be only described using the signs. They do not have any It's very difficult to, sometimes people are not aware of their names. So people can also show the signs, and from the sign only we have to extract the symptom information. So in this particular work, we have extended our work in the multimodal space. So symptom image aided symptom investigation and diagnosis. And also when we are extracting the symptom information from the images, we are considering the context. So in which context the user is showing the image, that is also important, and that helps us in correct identification of the symptom name. So we developed a multimodal disease diagnosis virtual assistant using hierarchical reinforcement learning and dialogue context aware symptom image identification and multimodal diagnosis dialogue data. We developed also our own data set because when we started doing research in this particular area, there was no data set available where users can also express the symptom using some images. So basically, we have collected our own data set for this purpose. So this is the overall diagram. So it remains very similar to the previous one. So the controller is a kind of a receptionist, and the departments are the workers, the departments. So first, thus based on the self-report, department will be decided, and then each department will do some symptom investigation, and the corresponding report will be generated, and the report will be given to the senior doctor for identification of the disease and proper prescription for generating the prescription. So now the only difference is this, that now the patient can also show some symptoms through the images. And we have this symptom image identification module. So this symptom image identification module is capable of extracting the symptom information from the images. And the internal symptom in module remains same. It is able to identify the symptom information from the text. And the symptom image identifier is a newly proposed, where based on the context, try to predict the symptom name from the given image. And disease classifier is a hierarchical disease classifier. So it will try to predict the department first, and then for each department there is a set of diseases. And finally, there is a diagnosis report which will be generated, and that report will be given to the senior doctor. Senior doctor will verify the report and will prescribe the medicine. So this is our user internal symptom information. So basically, we have two modules. One is for the extracting the symptom information from the image. For that, we have used the DenseNet 169 and the convolutional layers. And for the text part, we have used the clinical biobar, and we have concatenated them together. And then we are extracting the symptom information from the user's utterance. If the image is present, then this DenseNet will work, and if it is from the text, then the clinical biobar will work. So as I mentioned that there was no dataset available when we started doing research in this particular field. So in the conversational dataset that we discussed, like this MDD and the SD, so those were only having the textual conversations. So images were not part of the dataset. So we consulted one doctor, Dr. Meenakshi Dhar. She is a doctor in AIMS Rishikesh. So she helped us in identifying 20 visual symptoms which can have some signs. So which can be described using some images. So for these 20 symptoms, we collected the corresponding images, signs of the image symptoms from the Google API, and we collected total 1805 number of symptom images, and number of multimodal utterances is 725. So in this way, we have created our own multimodal dataset where there are 1500 number of dialogues, 6936 number of utterances, and each dialogue tag is having intent, symptom, image information. Average dialogue length is 4.62. Number of intents is 2. Number of diseases are 90. Number of symptoms are 266. Total number of symptom images is 1805. Total number of multimodal utterances is 725. So like here you can see like patient is showing, and these are the possible images. You can see skin irritation, these are the images. Mouth ulcer, these are the images. Skin growth, these are the images. Eye redness, these are the images. Hi, I have been like, this is an example conversation of our dataset. So this VSMDD is the image enhanced the MDD dataset. So in the MDD dataset, only the textual conversations are there, but now we have also added the images. Patient is saying, "Hi, I have been suffering from fever for a few days. Also, something happened in my mouth. Please see this." So here, you know that fever is a symptom, and also from the image we can extract that this is the mouth ulcer. So, did you recently vomit? Yes, I vomited recently. So here also, now one important symptom is basically the vomiting. Do you have eye pain? Yes, I am feeling so. So eye pain is also a symptom. Have you observed any skin rash in your body? I am not sure, but please see this. So he is showing some skin rash. So now finally the report is generated. The patient suffers from the following symptoms: fever, mouth ulcer, vomiting, eye pain, skin rash. The most likely disease is erythema multiforme. The images are shown below. So this report is verified by the senior doctor, and senior doctor will prescribe some medicine. So these are the results. So now we have shown the results of our image identification module. So how accurate our image identification module is. And as I mentioned, our image identification module is also contextual. So it considers the dialogue context. So what are said in the previous dialogues. So based on that, it is trying to extract the symptom information from the image. So we have done a window-based approach: context window 1, context window 2, context window 3, context window 4. So context window 3 is giving us the best result. We are getting 88.34% accuracy and 88.24% F1 score. And these are the results of our virtual doctor. So our success rate is 49.7%. Dialogue length in an average with the 10 number of utterances, we are able to identify the diseases. Average match rate is 10.12. Average match rate 2 is 31.54, and disease classification accuracy is very low, which is 40.90. So now we are basically working on how to improve the disease classification accuracy, because there are many confusions, there are many overlaps between the disease classifiers. So improvement over unimodal baseline is a state-of-the-art model. Human satisfaction. So basically, as we have shown that as now the user can also express the symptom information through images, the human satisfaction, this is not only, this is not only improving the result, but this is also improving the human satisfaction. Because as I mentioned that many people are not aware of many symptom information. So for them, showing some images as the symptom information is very much beneficial. So positive correlation between diagnosis success rate and the dialogue length. So basically, we are getting a moderate success rate of 49.7%. We are now working on how to improve this further. And also our observation states that dialogue context help. So if you are simply passing the image through the image identification module, and if you are also considering the context, in which context the patient has shown the image, so this context also matters. So this was all about the virtual doctor. Now let me discuss with you some other work where we have developed some motivational chatbot. So these motivational chatbots are some virtual counselors. So basically, that we have developed some data set, because when we started working in this particular field, there was no data set available. So we developed our own data set, and also we developed a conversational agent which can generate some motivational and the empathetic utterances. And this is our basically initially we have worked with only a depression patients, but later on we have extended our work for 4 mental disorders. And our algorithm works in 2 stages. In the first stage, it tries to identify the mental disorder type, and in the second stage, depending on the mental disorder type, it basically generates some empathetic and the motivational responses. So the motivation is very simple, that we are now after this post-corona, when we are mostly working from home. So this depression disorder is a widespread and serious medical illness. And survey by WHO estimates more than 300 million people worldwide are affected by depression. There is an increase of 18% between 2005 to 2015. Study from Suicide Prevention Resource Center in the USA reports that 45% of people who committed suicide had visited a primary care provider 1 or 2 months before their death. poor, and also we have a stigma. Even though we are suffering from some mental disorder, we do not want to visit any doctor. There is a mental stigma, and poor access and also number of psychiatrists is also very limited. Poor access, stigma, and discrimination likely limit the clinical care to only 50% who are affected by some mental disorders. And also, if you see the ratio between the number of mental illness patients who are suffering from mental illness and the counselors, is very alarming, especially in developing countries like India. So, in general, when suppose somebody is suffering from mental disorder or depression, there is a personal health questionnaire depression scale. So, the person is asked some questions, and there is a standard set of questions, and based on the answers of those questions, psychiatrists used to assign a particular value, which is called a PSU scale, to the patient. So mental health professionals use their personal experience to evaluate and give different levels of severity. So, with different levels of severity are also there. Some are very severe, some are moderate, some are mild. So this can also be done based on the experience. And for the mild one, maybe some counseling will help. For the severe one, we need some meditation. For the mild one, maybe some counseling will help. So with the continuously rising global burden of depression and mental illness, there is little to no effort in creating automated systems for reaching out to humans in times of distress and crisis. So the idea is that, can we develop some data, some virtual agent, which can basically, which can work as a virtual counselor. So if somebody is suffering from some mental disorder, this virtual counselor will be the first point of contact. It will be a shoulder to cry on. It will be simply a companion or a friend. So it will try to listen to the problems of the user, and then it will try to generate some motivational responses. So our motto is not to replace the psychiatrist. That is not possible at all. We simply want to develop something to help the psychiatrist, because the load on the psychiatrist is huge. And can we develop the fast point of contact? So initially, this virtual agent will try to increase the motivation, try to incorporate the motivation into the user's life. So when we started this research, we did not find any data set which is of this kind, because if you want to develop some virtual agent, you need a conversational data. Like I mentioned in the virtual doctor, we have this MDD or the SD data set, but here there was no such data set. So the first challenge was how to create such data. So my PhD student Tulika Shaha was working on this problem. So now she is a faculty in the University of Liverpool, UK. So she completed PhD from IIT Patna. So she only decided to work on this particular problem statement. And this work is in collaboration with a psychiatrist of AIMS Patna, Dr. Pankaj Kumar. So basically, our motto is to develop a virtual agent. So this virtual agent, the virtual agent's effort is directed towards comforting and allowing the users to share and express their thoughts, moods, feelings, emotions, struggles, and worries. The virtual agent should impart optimism, hope, motivation, which are identified as crucial affective factors to uplift the spirit of the users in distress. The virtual agent should be competent and proficient enough to give user a natural human experience by responding empathically and affirmatively. So basically, we have taken the results are also basically we developed such a virtual agent, and then we have we have compared the results in terms of some human evaluation metrics and also automatic evaluation metrics. And the best of our knowledge, this is the first work where we have applied natural language generation for the mental health. So as I mentioned, data set collection was not so easy. So as we are the first one to start working in this particular field, there was no existing data set. So what Tulika did is that Tulika searched for some forums. So in USA, medical forums are very common. There are many medical blogs and the medical forums like PsychoCentral, etc. Like these are the some medical forums, some such or GOV, Ask a Patient, Daily Strength, no WebMD, Ginger.io, Psychocentral. So these are different forums where you can anonymously, without revealing your personal information, you can register for these forums, and then you can discuss about your problem, the mental problem or your physical problem, with the other users. So there are multiple users in this forum, and then all, like if suppose you are asking a question, there are many other users who will try to give you some response, who will try to give you some suggestions. So basically we fixed to www.psychocentral.org, and then we collected some conversations. So we also registered as a user in this forum, and then we collected some conversations from this data set, from this from this platform. But the data set is of the form that, suppose somebody is asking a question, there are multiple answers of the question because there are multiple users. But for developing a conversational agent, what we need a question and a corresponding answer. It should be diadic conversation, it should not be a multi-party conversation. So with the help of the AIMS partner, Dr. Pankaj Kumar, we prepared some annotation guidelines, and then we employed some annotators, and they basically converted these multi-party conversations into some diadic conversations. And another motivation is to remove any kind of negative utterances from the dialogue. So, like if suppose there is a if suppose the patient is mentioning any like if there is some prescriptions or the drug names mentioned by the doctor, by some users, that is also removed from the dialogue, because our motivation is only to generate some motivational responses, but not to suggest any drugs or any meditation. So basically, you know that we scrapped around 5.5k multi-party conversations for the depression subforum, and the psychocentral is having several subforums. So the user can decide, user can classify himself or herself suffering from a particular mental illness, and then he or she can write on the particular subforum. So so depression. So basically, depression is such a subforum, and we have crawled the data initially from the depression. So next, the task is to modify these multi-party conversations into dialogue conversations, such that it resembles a motivational dialogue between a depressed user and the PA, imparting suggestion, hope, and motivation. So we consulted one of the leading psychiatrists, who is also the co-authors, currently practicing from a government-operated hospital of national importance, to help create guidelines for modifying the multi-party conversations. 3 annotators who are graduate in English linguists were asked to modify this multi-party into the diadic conversations. And we followed that these annotators followed some guidelines strictly. The annotators were asked to curate a turn-by-turn exchange of dialogues between the user and the VA from the responses of the poster and the commenter, and make maximum uses of responses from the source conversation to create a dialogue. Thus, a VA strictly cannot impart medical advice, because our motto is not to provide any medical advice, just to motivate the user. So any kind of utterances containing any kind of medical advices are removed from the data set. So finally, you can see that we have now created 4,000 dialogues. Number of utterances are 14,809. Number of utterances per dialogue is 3.70. Number of utterances per dialogue maximum is 47. Maximum user utterance length is 3327. Maximum he utterance length is 961. Number of unique users is 1000. Number of unique words is 59,363. So this is an example dataset you can see. Like Jen Cat is saying, I am really struggling to not take more sleeping pills and just pass out. I want to not wake up for a week. I want to take the easy way out and just sleep away. Virtual agent is answering, that's not you, Jen. John, not that's not you talking, Jen. It's a depression. Give yourself some TLC. Do something you love, like long bath with a glass of wine. Go online and play some mind numbering games. Retail therapy. Remember the butterfly effect. You are here for a reason that you are not allowed to know about. Hugs and keep venting. Jen Kerry saying, I double my dose to sleep. but I am still awake and typing fine. V is saying, virtual agent is saying, take a little nap, lie down for 10 minutes, shut off your computer now. It's the best thing for you. You won't be able to sleep unless you lie in the dark. Give it a try. Jenkat is saying, tired sleeping. And then my mom tells me we have to go. So I am out and about. I feel fine, maybe a little flurry and light. So VA is saying, tell me your mom about the pills so she can keep an eye on you. And please don't do this again. I worry for you. So I don't, then Jenkat is saying, I won't tell her because she will take them away and don't let me take any more. And I can't just stop suddenly. I will wait for my P-doc and tell him what's been going on. So VA is saying it's very easy to go from 2 to 3 to 4. The recommended doses is there for a reason. And unless you are a medical professional, you should follow what they say. So then finally, there are such conversations. The VA is saying you need to take responsibility for your thoughts, feelings, and behavior. It's not our fault we have this disease. We are not to blame, but we have to be responsible. Own it. Take care of yourself. This is a sample conversation from our dataset. And now the task is very simple that given a user's utterance, we have to generate a response. So the user's, the GenCat's utterance is basically the input, and the VA's utterance we have to automatically generate. So this is a natural language generation task. So basically, mathematically, it says that we have the user's utterance, and we also know the context, in which context the user has said that. Now we have to generate the response. So for that, we have used some existing models. So there are some sequence-to-sequence model and the HRED model. So in the sequence-to-sequence model, there is a encoder and there is a decoder. First encoder encodes the user utterance and decoder generates the response. So basically, we have developed these two models. And we use the recently introduced hierarchical encoder-decoder architecture where the conversation context or dialogue histories model using a separate RNN over the encoder RNN, thus forming a hierarchical structure known as the hierarchical encoder. So now there are different losses. So we are using the reinforcement learning based losses, like our we have to make a check that the agent should not generate any negative utterances. The agent should always generate positive utterances. There should not be any medicinal suggestion. So all are checked by the help of some reward functions. And these are some results. So you can see that we are the last row is our proposed approach. We have also done some human evaluation. So we can see that our human is also happy. Like when we have given some responses to the user to a human, and I asked them to rate the output of the virtual agent. So you can see that our proposed approach, the rating of the proposed approach is higher compared to the other approaches. So like rating of 5, we got for 35 utterances, and whereas the HRED2, where the reinforcement learning based reward functions are not there, has got 31 such ratings. So these are the examples you can see, like I am so depressed and overwhelmed with emotion that it hurts. I can't breathe. So ground truth is, I am sorry you are feeling this way. This is the actual response. Just know it does not last forever. When you feel this way, just to hold me on to that and look to the future when it would be over rather than live in the moment. Just remember it won't last forever, though it may feel the way. Take care. So our proposed agent is answer. This is the generating. I am sorry you are feeling this way. When you feel depressed, think about the future. Nothing lasts forever. Take care. And the other model is generating. I am sorry you are feeling this way. Things will change in future. Take care. So our model is generating more number of utterances compared to the other models. So now then, basically initially, as I mentioned, that we have only focused on the depression, but now in our next work, we have focused on some other mental disorders also. Like in this particular work, we have considered 4 mental disorders: anxiety, MDD, bipolar disorder, and the depression. So the motivation remains the same. An estimated 970 million individuals suffer from some sort of mental or neural diseases, making it one of the primary causes of disability globally. According to a recent WHO survey, more than 300 million individuals worldwide suffer from depression, a drastic increase of 18% between 2005 to 2015. So basically, what we have done is that here it works in two stages. In the first stage, depending on the conversation, so first when there is a patient and the bot will try to converse with the patient, and based on the conversation, the bot has to identify the disease, the appropriate mental disorder the patient is suffering from. And after identification of the mental disorder type, there will be different paths, because the anxiety, for the counseling for the anxiety is different from the counseling of the depression, or the counseling from the bipolar disorder is different from the counseling of anxiety. So this way there are possible different paths. So depending on the type of the mental disorder, different paths will be followed to motivate the user. So this way it basically works in two stages. First stage is the classification of the mental disorder type. In the second phase, different more paths will be followed to motivate the user. And also another important thing is the empathy. So when the responses are generated by the virtual agent, the responses should also have the empathy, because empathy or empathetic interactions is one of the fundamental factors in providing successful support, triggering positive outcomes in support-based conversations. Apart from empathy, imparting hope and motivation are also key effective factors to uplift spirit of the support seekers in distress in supportive conversations. So basically, our virtual agent will not only generate some motivational responses, but also some empathetic responses. So here we have extended the motive dataset. Now this motive dataset is having 4 different diseases, and the conversations of the 4 different diseases are part of the dataset. And also our proposed work is having 2 components. First is the mental illness classification framework, which tries to identify the appropriate mental disorder. And second is the mental illness condition motivational dialogue generation. So this is our proposal. You can see that based on the conversation, we are trying to identify the appropriate mental disorder. So it's a deep learning based approach. We are putting some attention, and then we are trying to predict what is the mental disorder the patient is suffering from. And then in the second stage, we are generating some responses. We try to generate some motivational and the empathetic responses depending on the disease type. So in this paper, we propose AI to propose a virtual assistant to provide support seekers with comfort and mental health support. As a first step, we create the motive dataset, which contains diary conversations collected from a peer-to-peer support framework, and then it does the classification followed by the generation. So as I mentioned that we have next we have worked on extending this generation into empathetic also. We are generating not only motivational responses but also empathetic responses. So to the best of our knowledge, this is the first work that seeks to incorporate empathy and motivation together in an end-to-end system for online mental health support. So we are first generating the motivational responses, and then we are converting those motivational responses into empathetic responses. So it's a pipeline based approach. The first module is responsible for generating the motivational responses, and the second module is responsible for converting these motivational responses into some empathetic responses. So first is the motivational response generator, and the second is the empathetic rewriting framework. So this is a pipeline approach. First, it is generating some motivational responses. These are the different scores: blue score, sentiment score, Russell scores. And then that output is passed through the empathy generation module. Empathy generation module basically inserts the empathetic words, empathetic phrases with the corresponding utterances. So that way, finally, we are able to get both motivational and empathetic utterances. So it's a pipeline approach. So the first model is trained on the motive dataset that prepared by us. And the second is already an existing framework called the partner. This is trained on an empathetic dataset and it is called the partner. So now let me discuss about some work on the cancer prediction. So this till now I was discussing about the conversational agents. and how conversational agents can be used to work as a virtual doctor or a motivational chatbot. Now, let me discuss in brief some developments of techniques for cancer prognosis.
Ma'am, I think Vivek has some question. He has raised the hand
Okay.
from long time.
Yeah, Vivek. Vivek, please go ahead.
Vivek, are you able to hear us?
Yes, yes.
Maybe by mistake he raised the hand. Then we can continue, ma'am.
Yeah. Okay, so Dr. Dilip, it will be fine now if we can also show some demo. Dr. Dilip?
Yes, yes, ma'am. Please.
Yeah, yeah, yeah. Yeah, let me just briefly discuss about this work and then basically show a demo of this virtual doctor. So basically, in this particular work, we develop some cancer prognosis prediction systems. So you know that cancer. If you know, cancer is a one of the deadliest disease, and a cancer patient can have many information or many multimodal information. So we have some images of the cancer tumors. We have some clinical data. We have some microRNA information, DNA information, copy number variation, genetic information. So, given all this data, the doctors used to get confused how to combine how to consider all this information, and then how to predict, whether the patient is going to survive for more than 5 years or less than 5 years. So, for deadly diseases, it is cumbersome and vulnerable for the human mind to visualize the complex information and plan the treatment accordingly. So, can we develop some AI based tools which can simply aid the doctors in taking some decisions? If, suppose, based on the information, the AI based tool can predict that the situation is very mild, or the what is the stage of the cancer, then accordingly, the doctors can also see the report, and then the doctor can decide about the meditation. So this way, for the prognosis purpose, what is to identify the stage of the cancer, AI-based tools can be used. So you know that according to the World Cancer Observatory, worldwide an estimated 19.3 million new cancer cases and almost 10 million cancer deaths occurred in 2020. So the global cancer burden is expected to be 28.4 million cases in 2040, a 47% rise from 2020. Female breast cancer has surpassed lung cancer as the most commonly diagnosed cancer with an estimated 2.3 million new cases. Breast cancer alone contribute to 24.5% of all females cancer estimated cases in 2020. So it's very much alarming. The situation is very alarming, and you can see it is the cancer mortality worldwide, the map. So basically, for the cancer, we have various information. From the patient side, we can collect various information. We can have some DNA, a complex molecule that contains all of the information necessary to build and maintain an organism. We can have the messenger RNA information, a single standard RNA molecule that is complementary to one of the DNA strands of a gene. MicroRNA information, a single a small single-stranded non-coding RNA molecule containing around 22 nucleotides. Copy number variation, structural variation in the genome involving both duplications and deletions. DNA methylene and the clinical details. So these clinical details can have the information of age at the diagnosis, size and grade of tumor, type of the surgery, type of the therapy, and also the image info. So we can have the histopathological images of the tumors. So from the images also we can extract some features. So basically what we have done, so I have a PhD student Nikhil Ananda Arya. So he is doing PhD with me. So he is basically investigating how can we consider this multimodal information of the cancer patients. Mostly he is focusing on the breast cancer and the skin cancer. And then we are trying to predict that combining all the information from multiple modalities, can we somehow predict whether the patient is will be surviving for more than 5 years or less than 5 years. If we can do this prediction, then that information can be given to the doctors, and doctors can decide about the medicines, or also can decide about the procedure of the diagnosis depending on these predictions. So basically, motivation of the work is that an intelligent system with extra computational capacity will help the oncologists and physicians to decide the correct treatment plan and prognosis of the cancer patients. So we just would like to, based on the multiple model information, we would like to predict whether the patient can survive for more than 5 years or less than 5 years. The correct prediction related to survival of the cancer patients would help the common people to spare from the extra expenses of unwanted treatments and toxic side effects of chemotherapy and radiotherapy. So in this particular work, we have considered three modalities: gene expression values, copy number variations, and the clinical details. So we collected this data set, Metabricks. This is the source of the data set. So cutoff years is 5. There are total 1980 number of patients. Long-term survivors are 1489. Short-term survivors are 491. Median age in diagnosis is 61. Average survival months is 125.1. So clinical, we are having total 27 number of features. For gene expression, we are having 224,368 number of features. For the copy number variation, we have 26,000 number of features. So we developed a deep learning based model. We first, did some feature selection, and then we passed them through the CNN based module to extract some hidden features. And then we concatenated all the feature vectors together. And then we passed through some classifier, which is the stacked, which is basically the random forest classifier for the prediction. So first, there are three modalities: copy number variation, clinical features, and gene expression. We did some feature normalization, and we have some normalized features. By applying PCA, we selected some important features from this existing feature set. And then we applied CNN to extract some, to identify some hidden features of the individual modalities. And then we concatenated the extracted features. And this concatenated feature set is passed through some classifier. Here we have used the random forest classifier. And the random forest classifier is predicting the decision whether the patient will survive for more than 5 years or less than 5 years. So there are two categories: short-term survivor and the long-term survivor. So this is the approach, that clinical data is passed through CNN, generating some hidden features. Copy number variation is passed through CNN, giving some hidden features. Gene expression data is passed through CNN, giving some hidden features. We are concatenating them. We are passing through random forest, and we are predicting whether the patient will survive for more than 5 years or less than 5 years. So with this model, we are getting the accuracy of 90.2% on the Metabrick data set, 84.1% precision, and sensitivity of 74.27%. And we have compared our results with respect to these evaluation metrics: accuracy, precision, sensitivity, specificity, and the Matthews correlation coefficient. And this is our proposed approach. Stacked RF is our proposed approach. And this MD, NNMD is the existing approach. So in this existing approach, they have not used the CNN to extract some hidden features. So by not using the CNN, they were getting 84.5% AUC value, 79.4% accuracy. But by using the CNN and by extracting some hidden features, and by stacking all the hidden features, we're getting 87% accuracy. So so these are some publications from my work. Like as I mentioned, that we are for the virtual doctor, we have publications in PLOS ONE, expert systems with applications, knowledge-based systems. We have also developed some sales agent, which we published in IJCNN or the ICONIP. And also there are some patents which are filed. And also there are some publications in recent years. We have publications in PMC bioinformatics, IEEE transactions on EI, AACL, ICPR, etc. And these are some references. So now I request, we have time, Abhishek, up to 8:50. So if you can show some demo of this virtual doctor. So before that, if you have any question, you can ask me.
So please, you may ask question from ma'am.
Okay, maybe Abhishek, you can continue.
Sure, ma'am. I'm sharing my screen.
Hmm.
Please let me know whether my screen is visible.
Yeah, it is visible.
Yes, yes, it
It
is
is
visible.
visible.
Okay, okay. Thank you, ma'am, for giving me this opportunity to share the work. So I'll be showing the demonstration and how you develop this virtual assistant in detail, and a few samples how it works, and detail about how we are planning for next few years, few challenges that you may take up and work on it. So this will be outline. So already ma'am discussed about the work, but I'll give you a little bit brief idea about the work, and then I'd show the development deployment, I'd show the demo and the few challenges, as I said. So these are the list of contributors. So uh, ma'am and Professor Pushpak Bhattacharya from IIT Bombay and Meenakshi Dhar from AIMS Rishikesh, we four are working on this project, and it has been more than around 1.5 year, and we are in a good position to have some kind of demonstration, and the virtual assistant that we develop, it is doing something that can be useful for doctors, at least in symptom investigation, not in diagnosis. As ma'am said, the motive is not to replace doctor, but to make an assistant that can help doctor. The final decision will be taken by doctor only, but the time, the investigation time, and the disease, it would be like a decision support system. So this is a project web page. So you'll click the link. Also, the QR code is here. You'll see all the work related to this virtual diagnosis assistant, from motivation to all works. Its GitHub page, its paper link, and everything will be there. All 4 or 5 page papers that we have published. Its media coverage and the demonstration that I will be planning to show. Currently, it's not open access. You cannot go and log in here, but we are expecting that it will be also done soon. So yeah, so this is the motivation. The main motivation was to assist doctor, because the number of doctors compared to population is very less. It's if you see this number, shortage of doctor is going to increase day by day. So we had two options: either to increase number of healthcares or to utilize their time more efficiently. The first option is not in our hand. It will grow gradually, right? So what we can do, we can assist the doctors with some technical means, and we took the path of the second thing to how to utilize their time more efficiently. And second thing was, in many rural area, doctor reachability is still a big concern. So you have to go 3 or 4 hours, and then you'll able to talk with the doctor. So why not to provide a first point of contact, like a virtual assistant that can do diagnosis at least, and forward it to some doctors, real doctors, and they can suggest and follow up on that. So I'll show the demo of this work only, what ma'am had told, a knowledge-infused context-driven dialogue agent for disease diagnosis using hierarchical reinforcement learning. The idea was pretty simple. The idea is that doctors don't go from one symptom to another symptom, like cold, then ask cough, then fever, then eye pain, then leg pain. They don't usually go. What they used to do, given the symptoms, when they find, okay, I have good enough symptoms, I can diagnose, so they hypothesize a set of disease based on only self-report. They don't hypothesize. So as patient said, I have a headache, they ask, okay, do you have a cold? Patient said yes. They ask, do you have also headache? Patient said yes. Now based on that, they may hypothesize, okay, patient may have the disease D, but they are not sure. So they first inspect the potential symptom of that disease D. If patient has cold, cough and fever, if he has also eye pain, then most likely he'll suffer from D, right? So they ask the next symptom, next eye pain, for example, here, to confirm that whether the patient is suffering from disease or not. So it's like if you see this diagram, so this is like symptom 1 to symptom 2, symptom 3, and then they hypothesize a potential disease. This is red box. So given the symptoms, what would be the disease? Let's say disease is D, they hypothesize this is the candidate disease, and they'll inspect the potential symptoms, crucial symptom of that disease. So they said, okay, do you have eye pain? And patient said yes. Then they have more confidence on that disease. It's like, if you see, they ask another set of symptoms, and patient said, no, I don't have. Then their candidate disease become changed. Now they're inspecting the other candidate disease. So it's like a differential diagnosis, and finally do the projections. It's like a continuous exploration exploitation. I don't know what patient do, so let's explore the symptom. Patient said cold and cough, I'll ask other symptom. Now based on that information, I'll exploit that information, whatever patient said, and utilize them to do efficient symptom investigation. So this was the idea. It's like a backtracking. Given the set of symptoms, I'll do candidate disease, I'll prioritize the symptoms, and then do diagnosis. This was the model architecture, whatever ma'am said. So in a hospital, when you go, there used to be like a receptionist. You say your self-report, hey, I'm suffering from teeth issue. They'll say you to go to dental department, right? So master policy is like that. Master is like a healthcare receptionist. You are saying, I have teeth issue. This is a state tracker is self-report or the conversation history. You are saying you have a teeth issue, and it will say, okay, go to the worker 2, which is a, let's say, dental department. You are going to dental department, there will be a doctor. So this W2, W3, you can consider as a specialist doctor or a department. So W2 will ask set of symptoms related to whatever you said. You said you have a teeth pain, they'll ask, you have also gum pain, you have also gum swelling, like that. And they'll confirm those symptoms. They ask you gum pain, and you say yes, fine. They'll ask other symptoms. If no, they may think, oh, it might not be my department. In such case, they'll again back to the master, forward it to the, like a receptionist, and they will direct you to another department. Once the master think the receptionistic, I have enough symptoms, it will call this disease classifier. I have enough symptoms, and based on that symptoms, it will diagnose. So this is the simple scenario, what it happens here. So this is what we are making. So it's like a robot, some mini robot. It will be like a healthcare receptionist, as I said. I'm calling it as her because we thought it is like a nurse. Huh? So you are going to say, hey, I'm suffering from headache and cold and cough, let's say. Then it will ask set of symptoms go as you say your problem. It will also have eye kind of, two cameras are there. It's making it like a humanoid because human can feel it like there is someone like a nurse, and it will ask you set of symptoms, and based on that it will say okay. It does your symptom investigation, and it has a kind of report that the patient suffer from so and so forth, and most likely disease is here, Ethereum multiform. This mini robot will say go to D4, say, and the patient when reached to D421, doctor will have the complete context about that the patient is suffering from mouth ulcer, vomiting, and skin rash and crozia, right? So they don't have to do much investigation. They with the given investigation, they think, yeah, it is Ethereum multiform, then they'll do the treatment part. If they think, no, if this is not correct, they'll ask more symptoms and confirm that disease, right? So there is no much risk. Doctor will always be in loop given the investigation, but this time will be saved. In a day, if doctor sees 100%, and if 2 minutes they invest on a investigations, the 200 minutes, which is like a 3 hours or something like more, which is very crucial for doctor, right? So this is our motivation to do some help in their investigation. So it will look like something like that. Patient comes, say, hey, I'm suffering from fever for a few days and mouth ulcer. The virtual assistant will ask question, patient will inform, and finally it will do diagnosis report. So in any point of time in this talk, you can raise your hand, you can unmute yourself, give suggestion, remark at any point of time. Feel free to do that, because I may miss something. So if you'll point out, it will be great. So this is what we had. So first we are making a software. We have kind of reached the software part and then the hardware part. So it's like a two-phase process. First software part, like a chatbot, and then it will have hardware part integration that I'll show you. So this is the hardware part that we are planning to do. So it will look like something, and these are the equipment. So it will have eye, because as ma'am said, many times you don't know symptom name. And it is true, even I didn't know what was the mouth ulcer. When I saw it, I said, oh, this is mouth ulcer. I used to say something like a chala, it has been happening in mouth. So many medical terms we don't know. So why not that? Leave it to doctor, leave it to virtual assistant. It can see and identify symptom out of it. I'm pretty sure most of you also don't know what is skin growth. But if you search on internet and find that this is the skin growth, then you say, oh, I know this is the something, but I didn't know the medical name is the skin growth. So that's why we are putting also camera kind of thing with the robot, that it can see the symptoms. The second problem in India is like many people don't know how to type in English. What to do then? Then it's like they can talk in Hindi, they can talk in some other languages, and there will be audio to text translation, and it will convert into text, and it will be done like that. So currently it cannot talk in across the language, but in future we're planning to do it's like a can talk across the languages, can see and understand also the patient emotional state, will have the sensor to, there will be IR sensor. So in COVID time you cannot touch things, so it's like only some distance it can sense the temperature, whether how much body temperature, so it will have the IR temperature, BP measurement on also like that. As I said, it's like a B2B, means it will go first to the hospital and clinician, and they'll use it. It cannot go to the end users because it's a healthcare thing, and you cannot take a chance for 1% also. So let me show that the link is active. So anyone can click this link, nlpgithub.io, and it will be able to see this web page. Then you can click on get started. You need to click, these are the models which you'll have, and then these are all our models whatever we are developing till now, and you can click on any of, for example, KICD, it's a knowledge infused context driven, whatever the ma'am has discussed. So here you have to do login. So when you click on login, it will say successful login. So here you will have the chat box thing, and you'll say I'm suffering from so and so forth. Currently it's not online, so it will ask other symptoms and go like that. Also there will be an image button, so you can upload the image of your symptoms, and it will be, when it will be green, the image will have been uploaded. For example, here it is. So this is how the interface will be. Again, you'll click on log out. You can click on any model. So it will first, it will not go to the end user, it will go to the doctors. Doctors will see how the bot is doing for its efficacy impression collection we are doing for that. So this is how it works. So I'll show you the demo in my terminal how it works. So for example, you can see few cases. So it's like a patient is coming and saying, hey, I have pain in eye, right? No, patient came and said, I'm suffering from lacrimination. And the virtual assistant asked this, do you have eye pain? No, I don't have eye pain. Then asked the virtual assistant, do you have diminished vision? And patient said, no, I don't have. Do you have symptom of eye? No. And based on like that, the patient, do you feel spots and cloud in vision? Patient said, yes, I'm suffering from such and such thing. Then based on this, whatever the symptoms it will ask, it will diagnose, okay, so based on the conducted symptom investigation, patient is likely to suffer from this disease, right? With the priority also, it is giving some priority with what chance it is doing that. So this is how it works. Currently the we haven't made it online because of some storage problem. In order to make it online, it needs to be something, one model weight needs to be 1 GB, less than 1 GB, but a lot of deep learning models are there and it's crossing that. That's why we couldn't able to make. Currently we are taking a cloud based system to do so. So this is how it works. And if you have any question or any suggestion, I'll feel free to take it, or I can show you the something related to how in hardware we are planning to do it like that. Also, I can talk about how you can how the deployment and the development has been done. Hierarchical reinforcement. We have used hierarchical reinforcement learning for developing this virtual assistant. So in reinforcement learning, what happens? It learns like a human. So it's based on the reward and penalty. For example, when I was a child, I was trying to explode everything. I was touching the fire. I was going and uh, doing everything like that. Because I was doing exploration, I didn't know what impact it will lead to, right? So this virtual assistant also has trained with the reinforcement learning technique. So patient comes and said, hey, I'm suffering from headache. Initially it asked, do you have a leg pain? And patient said no. Then it get to know, given the context, the leg pain was not appropriate, right? So for that, it got a penalty. In that way, it learned. Hierarchical reinforcement learning is a specialization of reinforcement learning, which says take a big problem, subdivide it into chunks of problems, You have a large problem and divide into chunks of problems. So here you have a large policy. So it's like a you have to do disease diagnosis across 10 departments. So why not to divide into different 10 departments? So this is like a worker 1, worker 2, and worker 3. And given the symptom report, it will identify which department it is. So there are 11 policies here in our case. In our case, there are 11 policies. First one is the master policy, and that's lower level hierarchy has 10 policies. So in total, it has 11 policies. So first one, what it does, it will identify department. In the second layer, do department specific investigation. So for example, you said you have a teeth pain and it will trigger the worker 2, and it is again a policy. Policy means a function which maps state to action. So you can regard it as only a simple S to A. S is a state and A is a action. Action you can think it as which symptom to ask. Whether should I ask cold or which should I ask cough, given the context. Context means state. And once it asks, okay, I need to, it asks, let's say cough, it will go to the hierarchical disease classifier. What it does, given the symptoms, whatever it has confirmed as of now, it will classify which disease it is. So let's say given the potential disease, as I said, doctors, what they used to do, they given the symptoms, they hypothesize a set of diseases, and it is known as the potential diseases. This potential disease will go to the PCM, potential candidate module. It's like a knowledge-based system. So for potential disease, which are the crucial symptoms, and this will be like a potential symptoms, which is infused as a learner critic. Critic is like a reward. The agent expected to ask this potential symptoms. If it doesn't ask, this learner critic will be negative. If it will ask, it will be positive, and it will be infused here. So in that way, we are reinforcing that behavior that it should, confirm the potential disease in case if it is the true. Otherwise, it will change the worker department. So in total, there are 11 policies. One neural net. We have used neural network for optimizing the policy. So this code and data, everything is available on GitHub. So if anyone interested can go there and you run the experiments and go dig into deep and see. Also for the other works, doctor can see, and symptoms are known by every code are available. So this is you can go and see for that. Maybe I can show you some test cases and discuss why agent is doing like that. That will be much better. In between, if you have any question and suggestion, please feel free to say. Okay, seems like no. So for example, if you see, this is the case, patient is saying, hey, I'm suffering from frequent urination. This is the user and saying, hi doctor, I'm suffering from frequent urination. Diagnosis is asking, do you feel sharp abdominal pain? Patient is saying, yes, I am suffering from sharp abdominal pain. Then the diagnosis is asking, do you have a nausea? Patient says, no. Do you have the pelvic pain? And like that, it's like a question answering. And at the end, finally, it is saying, okay, most likely you are suffering from this disease, cyclist with the priority, something like that. So there was one problem with the system is that when you do the backtracking, and with the hierarchical classification, when you use, you will have the subdivided disease space, and that the patient said, no, I'm not suffering from, let's say, frequent urination. So that negative information will not be utilized efficiently if there will be only use a single classifier, because that negative information also contribute in diagnosis. You asked, do you have a headache? And I said, no, that's fine. That information should also be utilized to differentiate whether the patient don't have headache, then most likely he or she don't suffer from D1, D5, and D7, right? So that information is missing, and this is one of the limitation of our work. As I said, given the set of symptoms, it is hypothesizing candidate disease, right? So if you see, given the context, the current probable disease and what the name is, the endomaterial, something like that, right? and the potential symptoms of that the candidate disease and so forth, and then it is asking those diseases to confirm. So if you see probability is increasing by something, initially it was somewhere, yeah, no, in this case it has not been increased. So I have seen the few cases where given the symptoms, probability was, I'll show you, yeah, here if you see, initially probability of this diabetic was some 0.52, and it asked, do you feel weakness, and patient say, yes, I'm feeling weakness. The probability of that disease increased by large margin, so 0.088, and finally the diagnosis assistant diagnosed it was the same disease, the patient is likely to suffer from this disease, which was true, I guess, here. So if I go and see, yeah, it is the diabetic something, the patient was suffering from that. So with respect to training and development, if anyone have any question, can ask.
Hi, Abhishek, Rajesh
Yeah,
here.
yeah,
Thanks for your
yeah.
demo. So in this case, you are maintaining the data set in file or any database. Means how you are maintaining these data sets? Uh,
How I'm maintaining the data sets. Okay, so this model has been trained on an existing data set, which is known as a synthetic data sets, which looks like, which has the 30,000 samples of patients. There are 30,000 diagnosis cases, and each diagnosis case look like this. Oh, seems like I haven't that slide. So each diagnosis cases look like patient self-report, what patient has said, and what are the implicit symptoms. Patient is suffering, but patient hasn't observed. If doctor will ask, then they can say yes, I'm suffering from that or not. And also the ground disease. So in a sample, there are three things: implicit symptoms, explicit symptoms, and gold disease, or the two disease. So it's like a database form, SD dataset, which has been trained. But in our next work, we have converted into dialogue form. If you see, to make an end-to-end system where patient can type, their concern in English, and agent has to understand that. Am I able to answer your question, or I missed? If missed
yeah,
your
yeah.
thing.
Somewhat is fine. I'm just asking, means a storage system what you are using, the as a file system or any database, and also for model you are
Hmm.
comparing the images.
Yeah,
So
yeah.
how you are storing that images, and uh, how you are comparing with the dataset, image dataset that is belong to particular disease.
Yeah, yeah. So here we put it name as like that. For example, this image name is S. If it is a dialog number D34, let's say, then this image name will be D34 underscore 5 or 6, whatever the utterance number will be this. So this is 1, 2, 3, 4. So fourth utterance, so its name will be D34 underscore 5. And that manner, when we are training, we are retrieving that information.
Okay, okay. So we are comparing the indexes,
Yeah,
index.
yeah, correct, correct.
Okay, okay. Thank you on that. And in the next part, in the critical
Hmm.
disease part, so you have tell that you have used a neural network technique.
True,
So
true.
so in that part, um, in the second part where we are choosing the departments, so there we have used reinforcement learning, and in the below part, PCM part, we have implemented neural network technique, right?
Yeah, true. So there are in total 12 neural networks, one for master policy, 10 for this, worker policies, and one for hierarchical disease classifier. Not one, it will be, or number of, here it was 10 again. So it is reinforcement learning network only, which is like a optimization problem. Given a state, you have to ask which action to be taken, and that optimization we have done through neural network. So it's the deep reinforcement learning. Reinforcement learning has been optimized with, neural network. So it is known as a deep reinforcement learning.
Okay. Thank you, Abhishek.
Yeah. Anybody else has any question, concern, or suggestion? Please feel free to do so. Yeah, so this will be the pipeline. If no one has any questions, I'll talk about the hardware integration that we had planned to do. So this is will look something like that. So it will be a client, and it's like a patient, and it will there will be the IoT devices. So a patient will say, "Hey, I'm suffering from this." There will be mic and camera for input collection. Patient will say, "I'm suffering from cold and cough." Finally, it will go to the cloud because will our model will happen in the cloud, and from there this input will be fed into the model, and model will give you the output. Finally, this output will be conveyed through a speaker or the wave. So this is how the interface will look like. And for hardware integration, these things we have bought, and finally integration will do it and see how it is doing. And these were the few research questions whatever the ma'am said. What this web page is available if anyone is interested to go. Whatever I am showing and saying, all the data set and codes are publicly available on our web page. Anyone can go and do the experiments, extend the work, read the paper, and do it like that. Also, the demo web page which I have shown you, link is there, but user ID and login password currently we haven't made it access. Because I showed you the demo in the terminal. So knowledge infused, whatever we discuss, multimodal disease diagnosis is like it is considering both symptom image as well as the image text concern, right? And symptoms are known by the companies. This was motivated by a simple idea. You must have heard that analogy that the main are known by the company, and that motivated to do very good research for what to wake and globe. So words are known by the company. In NLP community, this was like a remarkable invention. What to wake. So giving embedding for a word, giving a representation, numerical representation for a word. So it was developed with that concept only. Words are known by the company. So we thought, why not it will hold also for the symptoms. So for example, when I say cold, next thing most likely that coming in your mind is cough, not eye itching. So that association, cold and cough, is most quite often associated compared to cold and eye itching. That we investigated through in the experiment and found a strong correlation between these two. That association guides the agent to do better and efficient symptom investigation. That smooth transition happening. If you have patients say cold and you'll ask leg pain, although patients suffer from leg pain, the transition will not be very smooth. If you, for cold and you'll say cough and then you'll body pain and then leg pain, it will be quite smooth, right? The fourth question was, are all symptoms of a disease are equally important? For example, COVID, if I say this, that hit in my mind is a cold and cough, right? It's not eye redness, but eye redness was also one of the symptom of the COVID. And you're surprised to know when I had a COVID, I had only eye redness, nothing else. I figured not cold, not cough, not like that. So this is also one of the symptoms. So it's like, are all symptoms of a disease are equally important? Answer is definitely no. It depends on the context. So with the experiment we found, if you also consider the symptom importance in account for diagnosis, you'll able to do better diagnosis compared to when you are considering all symptoms as equally important. And this work recently published in Transaction on AI. So every work, whatever we have done, it's completely available and for research purpose, and anyone can work on it, can collaborate with us if anyone have any suggestion and remark, want to work with us.
Okay, Abhishek, I think we can stop.
Yes, sure.
Okay, so any question, if you are willing to ask, you may ask. So anyone? Okay, so thank you so much, Dr. Sipanna Shah ma'am, for your valuable time and sharing your valuable knowledge in AI ML application in digital health research with us. Your expert talk has provided us with invaluable insight about virtual doctor and its development. You vividly explain about knowledge infused context-driven dialogue agent for disease diagnosis that use hierarchical reinforcement learning and automatic disease diagnosis virtual assistant. Your explanation of the large-scale data set for motivational dialogue system, which is an application of natural language generation to mental health, was very insightful. You also explained on the development of techniques for cancer prognosis prediction and its application in healthcare. And also thanks to your research scholar, Mr. Sheikh Tiwari, PMR Fellowship, which is very reputed for his presentation on automatic disease diagnosis. Thank you once again, ma'am, for taking out your valuable time to impart us with your knowledge. Thank you, ma'am.
Thank you very much, Dr. Dilip, for this invitation. Yeah, many thanks.
Thank
We
you,
look
sir.
forward.
Okay,
Thank you,
ma'am.
ma'am.
Yeah,
So,
bye bye. Bye.
yes, I'm going to conduct your quiz after 10 minutes. Okay. So right now it is 8:51. Your quiz is going to be started by 9. Be ready. Okay. So just take break for 10 minutes. And it is compulsory, it is mandatory to receive certificate.
Yes, Mr. Gopal Rai.
Yes, Mr. Gopal Rai. What's your concern?
So please, I have shared the Google Forms link. Complete within 15 minutes. You are having the time. There is 20 questions. So please complete within 15 minutes. 9:12 you have to complete it. Those who have completed, they may leave because few have submitted. You are having only 2-3 minutes remain. So complete within 2-3 minutes because you have to complete by 9:12 and it is 9:09. So complete it. Last 1 minute. Your time is over. So I am going to remove the link. Those who have not submitted, they may not submit it. So complete if you have not submitted. Because Google Forms is not going to work. So please complete. Okay, thank you everyone. You all may leave it. Thank you because your time is over. Thank you everyone. You all may leave it.